all of its momentum, then the second one bounces off the wall, and then transfers all of its momentum back to the first, which then sails off towards infinity. 3 total clacks. What about if the first block was 100 times the mass of the second one? I promise I will explain to you all the relevant physics in due course. It's not entirely obvious how you would predict the dynamics here, but in the spirit of getting to the punchline, let's watch what happens. The second one will keep bouncing back and forth between the wall and the first block 100 times its mass, like a satisfying game of Breakout, slowly and discreetly redirecting that first block's momentum to point in the opposite direction. In total, there will be 31 collisions before each block is sliding off towards infinity, never to be touched again. What if the first block was 10,000 times the mass of the second one? In that case, there would be quite a few more clacks, all happening very rapidly at one point, adding up in all to 313 total collisions. Well, actually, hang on. Wait for it. Wait for it. Okay, 314 clacks. If the first block was 1 million times the mass of the other, then again, with all of our crazy idealistic conditions, almost all of the clacks happen in one big burst, this time resulting in a total of 3,141 collisions. Perhaps you see the pattern here, though it's forgivable if you don't, since it defies all expectation. When the mass of that first block is some power of 100 times the mass of the second, the total number of collisions have the same digits as pi. This absolutely blew my mind when it was first shared with me. Credit to the viewer